If we have the secant square ax plus b form, then we can write it as 1 by 8 and ax plus b plus c. Derivative of x is 1, integral of e power x is e power x, again integral of e power x is e power x. If you take this in the form of pi by 4, which is cos 45 degree, you can take it as 1, your answer will be minus 2. Pi plus pi by 2 means it lies in the third quadrant. So therefore I can write this as the value tan pi by 2, which is tan 90 degree, whose value is 1. Hence the value is equal to 1 by 3. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to revise the chapter Definite Integrals and Application to Areas. From this chapter, you will get one 3-mark question and one 5-mark question. So overall, you can expect 7 marks or 8 marks from this chapter. So let's see the 2 or 3 marks questions first, and later we'll discuss application to areas in terms of 5 marks question. So first let's see what are the 2 or 3 marks question you can expect. If the marginal cost is given by f dash of x is equal to 10 plus 6x minus 6x square, where x is the output, then find the total cost assuming that fixed cost is rupees 125. So we know that the total cost is the integral of marginal cost with respect to x as a variable here. So the total cost function can be written as integral of marginal cost with respect to dx. That is integral of 10 plus 6x minus 6x square with respect to dx. So applying the integral, we'll get this as 10x plus 6x square divided by 2 minus 6x cube divided by 3 plus integral constant. So therefore the total cost is given by 10x plus 3x square minus 2x cube plus c. So here the integral cost can be taken as the fixed cost, that is rupees 125. So therefore the total cost is 10x plus 3x square minus 2x cube plus 125. Next question, integral of x e power x dx. So limits are given, that is a to b from 1 to 2. So let us apply the integral by parts first. So first function, integral of secant minus integral of derivative of first, integral of second with respect to dx again. So the limits are given from 1 to 2. So we'll get this as x into e power x minus derivative of x is 1, integral of e power x is e power x, again integral of e power x is e power x. So here no need to write plus c because we are applying the values here. So that is from 1 to 2. Now let us apply the upper limit first. So we'll get this as 2e square minus e square minus, let us apply the lower limit, 1 into e power 1 minus e power 1. So 2e square minus e square becomes e square. So here e power and e power 1 cancels. So the value is e square. Next we have integral from 1 to 2 x plus e power x dx. So applying the integral for x, we'll get this as x square by 2. Applying the integral for e power x, it is e power x only. The limits are from 1 to 2. Let us apply the upper limit first. We'll get 2 square as 4 by 2 plus e square minus 1 square is 1 by 2 plus e to the power 1. So 4 by 2 minus 1 by 2 becomes 3 by 2 plus e square minus e. So this is the value. Next, integral minus delta by 4 to delta by 4 cosecant square x dx. integral of cosecant square x is minus cot x. So minus delta by 4, delta by 4. So here we'll get this as, if we take minus outside, we'll get here cot delta by 4 minus cot minus of delta by 4. So cot of minus theta can be taken as minus cot theta. So which becomes minus cot delta by 4 plus cot delta by 4. So which can be written as minus 2 cot delta by 4. So if you take this in the form of pi by 4, which is cos 45 degree, you can take it as 1. Your answer will be minus 2. Next we have integral of 1 to 2 1 by x dx. We know the integral of 1 by x is log x. So we have the limits from 1 to 2. So that is log 2 minus log 1. Clearly we know that log 1 value is 0. So therefore this is equal to log 2. Next question. Integral from 0 to pi by 2 secant square 3x. So if we have the secant square ax plus b form, then we can write it as 1 by a tan ax plus b plus c. So therefore, integral of secant square 3x can be written as 1 by 3 tan 3x. Now we can apply the limit from 0 to pi by 2 here. So 1 by 3 I can take it outside. Then I can apply the limit for tan 3x 0 to pi by 2. So here 1 by 3 tan 3 we have pi by 2 minus tan 0. The value of tan 0 is 0. So 1 by 3 tan 3 by 2 can be written as pi plus pi by 2. So which can be written as 1 by 3 tan, so pi plus pi by 2 means it lies in the third quadrant. So therefore I can write this as the value tan pi by 2, which is tan 90 degree, whose value is 1. Hence the value is equal to 1 by 3. Next we have integral 1 to 2 2x square plus 1 by x with respect to x. So after applying the integral, we'll get this as 2x cube divided by 3 plus log x here. The limits are from 1 to 2. Now let us apply the value of x as 2 first. 2 into 2 cube is 8 by 3 plus log 2 minus, next again we apply it as 1. So it becomes 2 into 1 by 3 plus log 1. The value of log 1 is 0. So here we have 2 8s are 16 by 3 plus log 2 minus 2 by 3, which can be written as 14 by 3 plus log 2. Next question. Integral 0 to 1 6x plus 1 square root of 3x square plus x plus 5 with respect to dx. So here we can take 3x square plus x plus 5 is equal to t. Now differentiate it on both sides. We'll get this as 6x plus 1 with respect to dx is equal to dt. Now since I am changing the variable here, we have a definite value, that is upper and lower limit. So let us change the limit with respect to t now. Now as x is equal to 0 here, as x is equal to 0, this implies t is equal to 5, and now as x is equal to 1 implies t is equal to 1 square 1 1, so 3 plus 1 4, 4 plus 5 9. So thus we can rewrite this integral as integral from 5 to 9. So here we can write t to the power, or we can write it as root t into dt, or we can write this as integral from 5 to 9 t to the power 1 by 2 dt. So after evaluating this, we will get this as t to the power 3 by 2 by 3 by 2, which can be written as 2 by 3 t to the power 3 by 2, and here we can apply the limits from 5 to 9. So let me keep 2 by 3 outside. We'll get the value as 9 to the power 3 by 2 minus 5 to the power 3 by 2. So here square root of 9 is 3. So then 3 cube can be written as 27. Next we have here square root of 5, or we can write this as 5 root 5. So this is the value. Next we have find the area under the curves y square is equal to 4x and x square is equal to 4y. So the application to areas from the definite integral will come under 5 marks question. So here we are supposed to find out the area under two curves. So we have two parabolas here. So the first parabola is a right-handed parabola, that is y square is equal to 4x, and the second parabola we have here x square is equal to 4y, that is the upper parabola. So we need to find out the area under this. So clearly we have a 2 point of intersection. So the first point is very clear, that is x is also 0, y is also 0. Let's find another point of intersection. Now from this equation we have y square is equal to 4x. We can write here y is equal to 2 root x. Next here in this equation we have x square is equal to 4y, or we can write y is equal to x square by 4. So from these two equations, let me consider y square is equal to 4x. I can write y is equal to x square by 4 from the second equation. So x square by 4 whole square is equal to 4x we have. So this can be written as x power 4. 4 square is 16. 16 fours are. So I can multiply it. So this becomes x power 4 is equal to 64x. Or I can write this as x power 4 minus 64x is equal to 0. Or x common, x cube minus 64 is equal to 0. On solving these two equations, we will get x is equal to 0 and x is equal to 4. So clearly, if x is equal to 4, then y is also 4. So therefore, this point of intersection, we can write it as 4, 4. So we have two methods to find out, one under the x-axis and another under the y-axis. So here, the area can be calculated as integral from 0 to 4. I am taking the x coordinates, f of x minus g of x with respect to dx. So if you take x in the form of a variable or x in the form of y, we need to take the coordinates limits from x is equal to 0 to x is equal to 4, f of x minus g of x. If you are taking the variable in the form of function x in terms of y, then we need to change the variable from y coordinate 0 to y coordinate 4, and here we need to substitute f of y minus g of y with respect to dy. So here I am taking the whole function with respect to x now. So we have 0 to 4, f of x, the first function can be taken as 2 root x, and the second function can be taken as x square by 4 with respect to dx. So let us integrate them. So we have 2 as a constant here, x to the power 3 by 2 divided by 3 by 2 minus, here you will get 1 by 4 into x cube divided by 3, integral from 0 to 4 we have. So clearly we can write this as 4 by 3 into x to the power 3 by 2 minus 1 by 12 into x cube, limits from 0 to 4. So apply the upper limit. Since the lower limit is 0, the whole equation will become 0. Apply the upper limit now. So we have here 4 by 3 into 4 to the power 3 by 2 minus 1 by 12 into 4 cube. So 4 by 3 into So square root of 4 is 2, 2 cube is 8. Minus we have 4 cube, that is 64, 64 divided by 12. So after evaluating this, we'll get the value as 16 by 3 square units. So this is the area between the curves y square is equal to 4x and x square is equal to 4y. Next question, we have find the area enclosed by the parabola y square is equal to x and x plus y is equal to 2. So we have a parabola and a straight line. So y square is equal to 4x and x plus y is equal to 2, a straight line. We need to find the area under this curve. So let us write the equation. We have y square is equal to x. This can be written as y is equal to root x. Next we have x plus y is equal to 2. So this can be written as y is equal to 2 minus x. Now here using these two equations we can take y square as 2 minus x. Now using these two equations we can take the value of y as 2 minus x. So from this equation we can write this as 2 minus x whole square is equal to x. So using a minus b whole square formula we have a square as 4, b square as x square minus 2ab as 4x is equal to x. Or I can write this as x square minus 5x plus 4 is equal to 0. On solving this, I'll get this as x minus 4 and x minus 1 is equal to 0. So from this factors, we will get x is equal to 1 and x is equal to 4. This I can find the area by taking the limits under x coordinates from 1 to 4 f of x minus g of x with respect to dx. So integral 1 to 4 root x minus 2 minus x with respect to dx. So this can be written as root x can be taken as x to the power 3 by 2 by 3 by 2. Minus 2 into dx can be taken as minus 2x. Minus into minus becomes plus here. This can be taken as x square divided by 2. Let us apply the limit from 1 to 4. So here, apply the limit as 4. This is 2 by 3 into 4 to the power 3 by 2. Minus 2 into 4 here. Minus 2 into 4 plus 4 square is 16 by 2. Minus, again we have here 2 by 3. 1 to the power, anything can be considered as 1, minus 2 into 1 becomes 2 plus 1 by 2. On solving this numericals, we'll get the value as 9 by 2 square units. So this is the required area. Next we have find the area under the curve y square is equal to x and x square is equal to y. Again we have two parabola. So the area will be the intersection of two parabolas. Let's find the coordinates now. So we have y square is equal to x. This can be taken as y is equal to root x. And we have x square is equal to y, or which is y is equal to x square. So taking the first equation y is equal to x square, we will get x power 4 is equal to x power 4 minus x is equal to 0, x cube minus 1 is equal to 0. So we'll get the coordinates as x is equal to 0 and x is equal to 1. Thus we can take the limits from 0 to 1. So the total area can be taken from 0 to 1, f of x minus g of x. F of x can be taken as root x and g of x can be taken as x square with respect to dx. Again this is equal to x to the power 3 by 2 divided by 3 by 2 minus x cube divided by 3, limits from 0 to 1. So let us apply this 1 to the power 3 by 2. So here it is 2 by 3 minus 1 by 3. And if we apply the limit as 0, this is completely 0. 2 by 3 minus 1 by 3 is 1 by 3 square units. Next we have Find the area bounded by the parabola y square is equal to 4x and y is equal to 2x minus 4. So, we have again here parabola and a straight line. So, y square is equal to 4x. This can be written as y is equal to 2 root x and we have y is equal to 2x minus 4. So, substituting y is equal to 2x minus 4, we will get 2x minus 4 whole square is equal to 4x. So, which is 4x square plus 16 minus 16x is equal to 4x. So, or we can write this as 4x square. 4x when it comes here, it becomes minus 20x plus 16 is equal to 0. Dividing throughout by 4, we will get x square minus 5x plus 4 is equal to 0. Again, we will get the same linear factor, x minus 4 and x minus 1 is equal to 0. So, thus we will get x is equal to 1 and x is equal to 4. Now, if you want the limits in terms of y, you can substitute for y here. If you take x is equal to 1 here, then clearly you can see y is equal to minus 2. And if you take x is equal to 4 here, then you will get y is equal to 4. So, therefore, the point of intersections are that is 1 comma minus 2 and 4 comma 4. So, thus you can take area in terms of x also or in terms of y also. I will just show you how we can write the area in terms of x as well as y. If you have x coordinates, then you can take it from 1 to 4 f of x minus g of x into dx. So, here you will take f of x as 2 root x and g of x as 2x minus 4. Or if you want to take the coordinate in terms of y, then the limits will be from minus 2 to 4. Here it becomes f of y minus g of y into dy. That means you need to take f of y in terms of x, where you will write f of y as y square by 4 and g of y as y plus 4 divided by 2. So, this is how you are going to work out. Now, I will take the x coordinates only. So, here area from 1 to 4. So, f of x I have taken as 2 root x minus g of x, which is 2x minus 4 with respect to dx. So, here integral from 1 to 4, 2 root x minus 2x minus 4 plus 4 here, because minus into minus is plus dx. After integral, we have 2 as a constant. Root x is x to the power 1 by 2. Applying the integral, we will get this as x to the power 3 by 2 divided by 3 by 2 minus 2 is a constant. Integral of x is x square by 2 plus 4 is a constant. Integral of dx is x. So, we have here 1 to 4 here. Now, 2 and 2 get cancels. So, this becomes 4 by 3 x to the power 3 by 2 minus x square plus 4x, limits from 1 to 4. So, let us apply 4 upper limit first. So, we have here 4 by 3. So, 4 to the power 3 by 2 minus we have 4 square plus 4 again it becomes 4 square minus, let us apply the lower limit. We have 4 by 3. 1 to the power 3 by 2 can be considered as 1 minus again we have 1 square 1 plus 4 ones are 4. So, now here after applying the limits and evaluating the value, so you can clearly see here 4 square get cancels. 4 cube is 64 and square root of 64 is 8. 32 by 3 will get in the first limit. And the second limit, we are left with minus 1 plus 4, 3. So, we will get the fraction. So, we will get 13 by 3. On solving this, we will get this as 19 by 3 square units. So, these are the few questions you can expect from the application of areas. So, from this chapter, you will get 1, 2 or 3 mark question of definite integral and 5 marks question will be on application to areas. So, this completes the revision of the entire syllabus of your second PUC basic maths. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.